1 plus x square into u dash. U dash is this one. That is, you can write here d by dx of x into cos x. Okay. Minus u into, u is x cos x into d by dx of root 1 plus x square. Okay. So now we have to do the differentiation of this one. Here 1 plus x square is there. This both root and square root both will get cancelled. Here minus also there. For whole minus is there. No? So keep here minus. The square and square root both will get cancelled. So root of 1 plus x square into d by dx of this. This is uv. Uv is there. That is x into cos x. Two functions are there. X is there and also cos x is there. So again you have to apply here one more rule. Okay. And here x cos x d by dx of root of 1 plus x square. So if we do the simplification of that, okay, now this f dash of x equals to minus root of 1 plus x square. Okay. Into this is again UV rule is there. So this is x you keep constant and cos x differentiation is minus sin x. Okay. Plus x differentiation is 1 here and cos x like that only. Cos x minus x cos x. This I have written there. And d by dx of this whole thing is in the form of root x. Just now I have told the root x differentiation. That is the root x differentiation is 1 by 2 root x. So 1 by 2 root x. But here instead of root x we have here 1 plus x square. So root x differentiation is 1 by 2 root x. Okay. X differentiation is 1. So you will write here 1. Instead of that, we write only 1 by 2 root x. But here in place of x, we have 1 plus x square. So again, we have to do d by dx of 1 plus x square here. Okay. So that means 1 by 2 root x. This is the formula of root x. And again, x differentiation is this part. So that is 1 differentiation is 0. X square differentiation is 2x. Okay. Divided whole divided by this both will get cancelled means only 1 plus x square. Okay. So that is minus root of 1 plus x square. This is cos x. You can write here cos x minus x sin x. Okay. Plus here 2x is there. No? This 2 and this 2 both will get cancelled. Okay, 0 plus 2x, no? Or else I will write one more time. X cos x into 2x by 2 root 1 plus x square. So 2 will get cancelled. Divided by 1 plus x square. Okay. Okay, now minus root of 1 plus x square. Cos x is there. Here if we take the LCM of the numerator, okay, here root 1 plus x square cos x minus x sin x minus, you write this step, okay, cos x minus x sin x minus x into x is x square cos x by root of 1 plus x square by whole 1 plus x square, okay. So now if we take the LCM, you will get a root of 1 plus x square. So if you do the cross multiplication, root 1 plus x square, root 1 plus x square. Means you will get whole square, no? That square and this root will get cancelled. So we will get 1 plus x square. Okay. 1 plus x square into cos x minus x sin x minus x square cos x by root of 1 plus x square by 1 plus x square. Okay. By 1 plus x square means this is numerator, denominator. After that again this is numerator and denominator. So it will be into, if we take this upside, it will be 1 by 1 plus x square here. So you can write this one as into 1 by 1 plus x square. Okay. So this is equals to 1 plus x square is there. Now you multiply this one with 1 plus x square. So you will get cos x minus x sin x. Next plus x square cos x minus x cube sin x minus x square cos x by, this is root of 1 plus x square. No, you can write it as 1 plus x square to the power of 1 by 2. And here 1 plus x square is there into 1 plus x square. Okay. So here power 1. So 1 by 2 plus 1 means you will get, if you will take cross multiplication, 3 by 2 you will get. If you multiply this one and this one, you will get it as 1 plus x square to the power of 3 by 2. Okay. And here this plus cos square x and minus cos square x both will get cancelled. So you will remain only cos x minus x sin x minus x cube sin x divided by 1 plus x square 3 by 2 you will get. Okay. And if you do the simplification of this one, that is cos x minus x sin x minus x cube sin x by 1 plus x square 3 by 2. You can keep like this, or else you can change this one, that is cos x minus, you can take here x and x sin x is there, x sin x is there. So you can take here common, that is cos x minus x sin x. If you take out common, what will be there? This is 1. Okay. If you take out x from these two terms, you are taking x sin x common. So 1 minus is there. So here plus, minus into plus means minus you will get. X sin x, if it will go, what is remaining here? X square is remaining. Okay. 1 plus x square by 1 plus x square to the power of 3 by 2. Okay. This is the simplification of that one. And again, you can write this one. You can split this one, that is cos x by this one, and this part by this one. Okay, that is cos x by 1 plus x square into 3 by 2 minus x so here minus x sin x into 1 plus x square by 1 plus x square to the power of 3 by 2. Okay. From starting, we have here minus sign. No, here also minus sign will be there for whole minus. Okay. So minus of minus means here you will get the plus side. Minus cos x by 1 plus x square by 3 by 2 plus this one. So you are going on making it in a simpler form. Okay. So last one is 1 plus x square 3 by 2 is there. Here 1 plus x square is there. Means here power 1 no. In the denominator what we have? 1 plus x square 3 by 2. Okay. If this will go to the numerator, or if numerator it will come to denominator, it will become minus 1. So means x is 1 plus x square 3 by 2 into 1 plus x square into, if this numerator comes to the denominator, minus 1. That is 3 by 2 minus 1 means 3 minus 2. 1 by 2 you will get. Okay. That is minus cos x by 1 plus x square into 3 by 2 plus x cos x x sin x by 1 plus x square. That is root you can write. Root 1 plus x square. This is the answer. Okay. So u by v means somewhat lengthy it will be there. You have to do here somewhat complicated it is there. That's why we have done many steps. If it is the problem given one is the very simple one, then easily you can solve that problem. Okay. This is the procedure for finding the u by v differentiation. Okay. Next we have if y equals to log cos h2x, then find dy by dx. That is a hyperbolic function it is given. For the hyperbolic function, we have to find the differentiation. First order differentiation we have to find. Okay, if y equals to log of cos h2x, find dy by dx. Okay. Okay, given that y equals to log of cos h2x. Okay. So you can take this as 1 and write here differentiate 1 with respect to x on both sides, or on differentiating 1 with respect to x on both sides, we get phi differentiation means dy by dx is equals to, this is in the form of log, whole thing you take as x, log x. Okay, this whole thing first you consider it as x. So log x differentiation is 1 by x. Starting I have told the formula. Okay, so log x differentiation is 1 by x. 1 by x means instead of x, what we have here? That is cos h2x. Okay, and here only if x is there means 1 by x is enough. But instead of x, we have cos h2x is there. That means you have to do even this differentiation of this term also. So cos h2x differentiation is cos, here again 2x is there. Only cos hx means directly we can write sin hx. But here instead of x, we have 2x. So cos h, you consider this whole thing as x first. So cos h x differentiation is sin hx. That means into sin h2x. Okay. First here instead of this whole thing, you take it as x. So log x differentiation is 1 by x. And again this x differentiation we have to do. So x is cos h2x. So consider this as x whole thing. So cos hx differentiation is sin hx. And again one more time you have to do differentiation. Why? Because instead of x we have 2x. So 2x differentiation is 2 into x. X differentiation is 1, so you will get it as 2. Okay. So for such problems, you should not get confused here. Log this whole you consider as x. So log x differentiation is 1 by x. But what is our x? X is cos h2x. And again x differentiation will do no. So x means this cos h2x. This differentiation is this one. And again instead of x we have 2x. So this differentiation is this one. Okay. X 1 by x. This is x differentiation. This is 2x differentiation. So now if you do this is 2 here sin h 2x by cos h 2x. Sin by cos means we'll get tan. Okay. So it is equals to 2 tan h 2x. So the answer is this one. Okay. Only simply if any 2x or anything is there, means somewhat easy will be there. But here we have log of cos h2x. So don't get confusion. Don't do mistake here. The procedure is you have to consider the whole thing as x. And then you have to do the differentiation. So log x, 1 by x, x differentiation is this one. This differentiation is this one. Okay. If we do the simplification, you will get the answer. So next, we have another method that is finding the derivative of a function which is in the form of function to the power of function. Okay. Find the derivative of the function so f of x is equals to x to the power of sine inverse x. Okay, this is the given function x to the power of sine inverse x. So if you check the formulas before I have given, there you are not having any formula for x to the power of x. If you consider that sine inverse x. So if whole thing is this, x to the power of sine inverse x. So we have seen the formula for x to the power of n. And even for a to the power of x. For this we have formulas are there. X to the power of n means n into x to the power of n minus 1. A power x means a power x log a. Okay. But we are not having, this is one function, this is another function. That means function to the power of function. Here is asking to find the derivative of such function. Okay. Whenever such problems are there, which are in the form of function to the power of function, we have to apply the logarithm on both sides. Okay. We have to take logarithm on both sides. Then it will be converted into simple form. Then you have to do the differentiation. Okay. Direct formula is not there for such problems. Okay. Now given that f of x is equals to x to the power of sine inverse x. Okay. Taking logarithm on both sides, we get that is log into f of x equals to log of x to the power of sine inverse x. Okay. So this is same, it will be there, but it is in the form of log x to the power of n. Okay, anything to the power of. So log x to the power of n means we'll have the formula n into log x. Okay. Here also it is similarly log x to the power of n. So it will be sine inverse x. You will get here sine inverse x into log x. Okay. If you want, you can write here log x to the power of n is equals to n log x. So that concept we are using here. Okay. Now we got sine inverse x into log x. So sine inverse x is one function, log x is another function. Now it is in the form of UV form. Okay. So we have to write that. So this you can take u and this you can take v. Okay. So here f of x equals to x to the power of sin x is there, no? You can take this one as letter. Instead of f of x, you take as y. It will be easy for solving this one. Okay, let y is equals to y, because we'll take the function as y equals to f of x. So instead of f of x, here we are taking y. So instead of f of x, you consider it as y. So y is equals to x to the power of sin inverse x. Only for solving the problem, just I am telling, okay, into y. Okay, so this is log y is equals to this one. So if you take this as equation 1, on differentiating 1 with respect to x on both sides, we get log y means it is in the form of just log x. Log x differentiation is 1 by x. Like that only log y differentiation is 1 by y. Okay. But we are doing with respect to of the variable y. Whenever other than x, if you have any variable, then we have to do the differentiation of that variable. Okay. So that is again you have to write dy by dx. So differentiation of this variable. That is 1 by y is the differentiation of log y. Log y is 1 by y into dy by dx equals to. This is UV method. So sin inverse you keep constant, sin inverse x into log x differentiation is 1 by x. So don't get confusion here. Y term we are doing. So whenever y term is there means that is dy by dx. Here also we'll do actually. Log x means 1 by x into dx by dx. Dx by dx means its value is 1. So whenever we'll do the differentiation with respect to the x variable, we'll not write again one more differentiation. Whenever y or z or t, any another variable is there, for that variable you have to write dy by dx, dt by dx or dz by dx. Okay. If with respect to x variable you are doing, that value will be 1. Okay. Remember that. Don't get confusion here. So plus again log x you keep constant into sin inverse x. Sin inverse x differentiation is 1 by root of 1 minus x square. Okay. Now what we have, sin inverse x 1 by x. So this is 1 by x sin inverse x plus log x by root of 1 minus x square. Okay. So here dy by dx, therefore dy by dx is equal to, if you take cross multiplication, this will be, here only you take. So this is dy by dx is equals to this y, if it will come here, y of this value. Okay. So what is y? Y from the given question, y value is x into sin inverse x. To substitute here that value, that is x to the power of sin inverse x into sin inverse x by x plus log x by root of 1 plus x square. So this is the differentiation of the problem. Like this, you have to solve whenever function to the power of function is given. Okay, this is the procedure. So direct formula is not there. So formula is not there. So you have to apply the logarithm on both sides. Then you have to convert it into the simple form such that we can do the differentiation here. So we have converted here its simple form. Then we have differentiate. So you, after doing the differentiation, you will get the answer of the given function. Okay. So this is the one method we have.
Ma'am, in that equation, how we got under root 1 minus x square?
This is the differentiation of sin inverse x. I have given formulas now just now. So UV rule, no? UV rule means here you have keep two constant. Log x differentiation is 1 by x plus log x constant. Sin inverse x differentiation, no? So sin inverse x differentiation is 1 by root of 1 minus x square. Okay. Sin x differentiation means cos x, no? Like that only sin inverse x differentiation is 1 by root of 1 minus x square. So this is direct formula. So that means again I have not written. Directly we have written no, log x differentiation is 1 by x. Here sin inverse x differentiation is this one. Okay, understood?
Okay, ma'am.
If you want, you write here in the brackets. Since sin inverse x differentiation is 1 by root of 1 minus x square. Okay. So this also with the 5 marks problem you have. Next we have the concept of finding the higher orders. Only this is a first order, no? So next we have the concept of finding the higher orders, means second order, third order, like that, any other orders. If is asked in the examination, means we have done here first order. If we do for this only one more differentiation, then we call it as a higher order or second order. Sometimes n orders will be there. There is nth order also will be there. But almost you have only the second order is there. Second order problems are there. So we have next find the second order derivative of e power x sin x cos x. Here actually 3 functions are there. So 2 functions means it will be easy one. But we have here 3 functions are there. For the 3 functions at a time we have to find the 2 orders. That is the first order and also second order. Completed, I think so. I am rubbing this one. Okay. Find the second order of find the second order derivative of e power x sin x and cos 2x. Okay. So this is one function, this is one function, 3 functions are there. E power x is there, sin x is there, cos 2x is there. Okay. So we have to find the second order of that one. So u, v, w. If only first order is asked, it means we can use the formula for the u, v, w. That means at a time 3 functions you can do the differentiation. But is asking second order, which one more time you have to do. So that will be very lengthy process if you will use that formula. Okay. So you have to make it into simpler form and then you have to find the differentiation of that one. Okay. So you in the solution you write let y is equals to e power x into, just you take out here cos x first and then you write sin x here. Okay. Multiplication is there, so you can write here any term anywhere. Okay. E power x into cos 2x into sin x. So here at 3 at a time we can't do that. That is differentiation. We can do first order differentiation. 2 terms you have to keep constant and you have to do the differentiation of the third term. Like that only 3 times you have to do. And again second order means again more 3 times you have to do. Okay. Like that also you will get the answer, but somewhat it will be complicated one. So you are making it into simple form. So for that you consider first take these 2 terms. That is cos 2x into sin x. So this one we have to convert it into the formula, that is 1 by 2 into 2 cos 2x into sin x. Okay. This in trigonometry, that is a trigonometric functions you will have, no? In that you will have some formulas will be there, trigonometric identities. From that you are converting this one. Okay, that formula writing here sin a plus b into minus sin a minus b equals to 2 cos a sin b. 2 cos a sin b. Okay. So this from this formula we are converting this one. That is here cos a sin b is there. 2 cos a sin b. Cos a sin b, 2 is also not there. So what we have done, cos a sin b means 1 by 2 into, that is dividing and multiplying with 2. If both this it can if they get cancelled, you will get the same term. Okay. So you are converting this in the form of this. So 1 by 2 into 2 cos a sin b. When you will get this one? When you do sin a plus b minus sin a minus b. So here Sine here, this term is A and this term is B. Okay. This term is A and this term is B. Means A value is 2x, B value is x. So you are converting this as like this. That means sine 2x plus x minus sine 2x minus x equals to this one. This answer is this. You have to write for this one, these terms. Okay. So from the one trigonometric identity, we are converting this one. So if both will get cancelled, you will get the same term. So multiplying and dividing with 1 by 2. So this part is there here. We have to convert it into this one. So 1 by 2, you take outside. So 2 cos 2x into sin x. Okay. This one is equals to sin A plus B. So this is our A and this is our B. So A plus B means sin 2x plus x minus sin A minus B. That is 2x minus x. So what you get answer? This is sin bx minus sin 2x minus x is x. So for cos 2x and sin x, we got the answer as, that is, we have converted it into simple form as sin 3x minus sin x. Okay. That is here 1 by 2 is there. No? So you have to take here 1 by 2 of so 1 by 2 of this term. That means 1 by 2 of this. Okay. So instead of this 2, that is cos 2x and sin x, you write this value. So y is equals to e power x into 1 by 2 sin 3x minus sin x. Okay. Now you take out 1 by 2 outside. Now this is e power x. If you multiply this, e power x into sin 3x minus e power x into sin x. Okay. Now you can do the differentiation of this one. So you take this as 1. So differentiate 1 with respect to x on both sides. So what you will get? Differentiation of y is y dash. Y dash is, or you can write dy by dx, anything. Okay. So 1 by 2 into e power x into, again this is UV rule. Okay. E power x into sin 3x. So e power x keep constant. Sin 3x differentiation is 3 into cos 3x plus e power x differentiation is e power x only. So e power x sin 3x minus, again this is also UV rule. E power x constant and sin x differentiation is cos x. Here minus is sign is there, so I am writing here minus. Minus of e power x differentiation is e power x only. So e power x and sin x is constant term. Okay, this is the answer for only y dash. So if you see the one more time, means 2 terms we have to do now. He is asking in the question to find the second order differentiation. So you can take this as 2 and differentiate 2 with respect to x on both sides. So we get it. So one more means y double dash. 2 times we have to. So again you will get here all UV method.
Can you repeat the second equation?
So one more time differentiation means 1 by 2 into. So this is again UV. U and V. So 3 e power x into cos differentiation is minus sin. Minus sin 3x into 3. Again 3x differentiation is 3. Okay. And again, this one more time. So plus 3e to the power of x cos 3x. Okay. Only this part we have done. Again, this part means plus e power x. Sign differentiation is cos 3x into 3 plus e power x sin 3x. Okay, this is second one. Next, this one minus e power x cos x differentiation is minus sin x. Okay, minus e power x cos x. There is a third term. Next, again, fourth term minus e to the power of x cos x minus e to the power of x sin x. Okay, these many terms you will get. So if any like terms are there, then you can add. And if any positive and negative terms are there, you can do the cancellation of the term. So it is equals to 1 by 2. This is 3 3s are 9. E power x minus sin 3x plus 3e power x cos 3x. So here 3 e power x cos 3x is there. Here also 3 e power x cos x is there. 3 plus 3 means here 6 you will get. 6 and next sin 3x. Here plus e power x sin 3x is there. Here we got minus 9. These are minus 9 and plus. So you'll get minus 8. Here minus 8 e power x sin 3x. So these two terms we have added, these two terms we have added. Next, e minus of minus is plus e power x sin x. And this minus e power x sin x, this both will get cancelled. And another one is minus 2 e power x cos.
Ma'am, can you repeat from second equation?
This one?
Yes.
So we have done the differentiation of this one, no? This is uv. So uv means here we have taken e power x constant. So sin 3x differentiation is cos 3x. But quotient is 3 is there. So you have to take here 3. Okay. That means 3 cos 3x is the differentiation of sin 3x. Plus this one only, uv. So one time we have done, second term is e power x differentiation is e power x. Sin 3x differentiation, sin 3x is constant term. So you keep like that only. Here e power x differentiation is e power x. Minus term. And again this is uv rule. That is e power x. Sin x differentiation is cos x. Okay. This is minus. Why? Because here minus sign is there. So minus e power x differentiation is e power x. This is the constant term. Okay. So here no like terms are there. Here 3 power x is there. 3 power x sin x cos x is there. This is only first order. Okay. The question is asking the second order. So for this you have to do one more time differentiation. So one more time means it is the y double dash. 1 by 2 you take constant term like that only. So this is uv, this is uv, this is uv, this is uv. That means 1, 2, 3, 4 terms are there which are uv. Again 4 means 8 terms you have to get here. So this is 1, 2, 3, 4, 5, 6, 7, 8. You are getting the 8 terms here. So again for this you do the uv method. E power x. This is constant cos 3x. Cos 3x differentiation is minus sin 3x. 3x 3. So here 3 3s are 9. So before I have written 9. And again here 3 into e power x differentiation is e power x. Cos 3x is constant. So cos 3x is constant. Next for this also same. E power x sin 3x differentiation means cos 3x.
Cos 3x.
To 3 plus e power x sin 3x. Again minus of, here minus sign is there. So minus e power x is constant, cos differentiation is minus sin x. Okay. So again, one more time now. So minus e power x differentiation is e power x, cos x is constant. Okay, minus of e power x, sin x differentiation is cos x, minus e power x differentiation is e power x, sin x is constant. Now you do the simplification of that one. Okay, so here 4 UV methods are there, means again 4 terms you will get. Remember that. So 8 terms you will get from this. Sin 3x is there, here sin 3x is there. Here minus 9 plus 1. So minus 8 e power x sin x 3x. So 3x cos 3x is there, 3x. 3 plus 3 6 e power x cos 3x. Here minus of minus, it will become plus. So plus e power x sin x. Here minus e power x sin x is there. Both will get cancelled. Here you have the negative sign is there. So if you add that, you will get e to the power of x cos x. So second order derivative is this one. Okay, if you have 2 terms, it will be easy, but 3 terms are there. No? That's why it's a somewhat complicated one. 3 cos 3x. Okay, this is the answer for the second derivative of the given function. Next, we have the concept of the partial differentiation is there. On partial differentiation, finding the second order, we have that problem is there. So in partial derivative, we have one problem if, and I have told if any function is there, z is any function such that if we have the function as x square plus y square, partial means we'll write the term like this, dou z by, and also here partial differentiation will do with respect of variable x and with variable y different. That is dou z by dou x equals to 2x, and dou z by dou y means here y square is 2y. Okay, so we'll do the separate for the variables here. So that is the difference between normal differentiation and partial differentiation. So on this we have one problem is there. That is, if u is equals to e to the power of xy, then show that u into uxx So on partial differentiation also some example problems we have in your textbook. Okay, once you check those problems, this is the exercise problem I am telling. If u is equals to e to the power of xy, then show that u into uxx plus uyy is equals to u square, that is x plus uy square. Okay. So here, if we write here ux means this is first order. Okay. If 2x are there for the base, it is called as the second order. So this is second order and this is the first order. Okay. So here u value is given as e to the power of xy. Then we have to show that u into uxx plus uyy is equals to ux square plus uy square. Okay. First order square and second order square is equals to, that is a, here whatever first order of partial differentiation of u and y is equals to this one we have to show. Okay. So for this, first you find ux means first order. Given that u is equals to e to the power of xy. Okay. So differentiate one partially with respect to x and y on both sides. Okay. So ux means this is partial differentiation with respect to x. So ux means we have to do only the differentiation of x variable. But here multiplication is there. So e to the power of x, take first whole thing as x. So e to the power of x differentiation is e to the power of x only. Okay. And again, here we are doing with respect to x. So this value is 1, x differentiation is 1. You will get as y into e to the power of xy. Okay. This power, okay, power differentiation means x differentiation is 1, What is remaining? Y is remaining. So you write that as a quotient. Okay. Next, U with respect to Y. Okay. So this is same. When we are doing with respect to Y also, this whole thing you consider as X. So e power X differentiation is e to the power of XY. Now XY differentiation means here X is the constant term. So you are writing that constant term. What is Y differentiation? Y differentiation is 1. So that is actually X into 1. But instead of that, I am writing here X into e to the power of XY. Okay. This is the first order differentiation. Next, if you take this 2 and 3. One more time, if you take the differentiation, differentiate 2 partially with respect to X and Y on both sides, we get. So one more, second order. So U XX. So for this only you have to do one more time differentiation. Y you keep like that only. And e power xy differentiation is e power xy only. Again you will get one more y, no? This is whole thing is x. So you will get here y square. And similarly, u y you will get it as x square into e to the power of xy. Okay. Now we got ux, uy, uxx, uyy. So all these 4 values substitute in the given one. So u into this part, whatever you are getting answer, that should be equal to this one. That is asking in the question. Okay. If both the values are same, then we can tell that these two are equal. Okay. U into.
Ma'am?
Yes.
Can you please once more explain uxx and uyy?
So this is the ux, no? So one more time, if you do, what will happen? One more y you will get, no? Y into e to the power of xy. Okay, y you keep like that only. E to the power of xy differentiation is e to the power of xy only. Again, in x into y differentiation, what you will get? Y. Already y is there. So y into y means y square into e to the power of xy. Understood? This part is there, no? This for this we are doing one more differentiation. Y into e to the power of xy. Okay. So for e to the power of xy, you keep y as a constant like that only. For e to the power of xy, you are doing the differentiation. E to the power of xy differentiation is again e to the power of xy. Xy differentiation means x term you will get as that is 1. And what is the quotient? Y is there. So y already is there. Y into y means y square. Okay, similarly here also. E to the power of xy differentiation is e to the power of xy. And in xy, y term is 1. So x quotient is there. Already x is there. So x into x is x square. Okay, understood? So now u into uxx plus uyy. So here we are not applying the UV rule here. UV rule will be not there in this partial differential equation. Y term, whatever it is there, you keep constant like that only. Again, e to the power of xy differentiation. E to the power of xy differentiation means e to the power of xy only. And x differentiation is 1. So y is remaining quotient. So y, already y is there. So y into y means y square. Here also similarly x square into e to the power of xy. Okay. So now u into uxx plus uyy. So what is our u? U is e to the power of xy into uxx value. Y square into e to the power of xy plus x square into e to the power of xy. Okay. So if you multiply this one, what you will get? Y square into e to the power of xy whole square. E to the power of xy, e to the power of xy. So e to the power of x whole square plus x square into e to the power of xy whole square. Okay. So what is So we need to show that ux whole square and also uy whole square. So ux value is what? That is y is there. So y square into e power x whole square. That is only the same. So this is equals to y into e to the power of xy whole square. We can write like this now. So when you take out y square into e power x whole square plus x into e to the power of xy whole square. So what is y into e to the power of xy? Y into e to the power of xy means ux and uy. This is uy. So we got the answer. So it is equals to ux square plus uy square. So from 2 and 3, from 2 and 3 we got ux square plus uy square. So therefore u into uxx plus uyy is equals to ux square plus uy square. So like this we have to solve the problem for the partial differentiation. So this is the exercise problem we have seen. Next we have differentiate the ideal gas equation is there. PV equals to nRT with respect to T. Differentiate the ideal gas equation PV equals to nRT. Differentiate the ideal gas equation PV equals to nRT with respect to T. Okay. So given that PV equals to nRT. So if you take this as equation, differentiate one with respect to T on both sides. So with respect to T means d by dt of PV is equals to d by dt of nRT. Okay. So this is UV rule. P is one function is here and V is the pressure and volume we have. Okay. So this, if we do with the help of the UV rule, we'll get V into dP by dt plus P into dV by dt. Okay. P into dV by dt plus V into dP by dt equals to N and R. These two are constant term now. N is the number of moles here and R is the universal gas constant. So these two are the constant terms. So if you take out them outside, d by dt by dt. Okay. This dt by dt value is 1. So you will get it as nR into this value is 1. So this V into dP by dt plus P into dV by dt is equals to nR. So this is the differentiation of ideal gas equation PV equals to nRT. So like this, you have to find the differentiation when any equation is given by applying the UV rule here. And this is the term you are doing with respect to of T. dx by dx value is 1. No? Same like that, only dt by dt value is 1 here. Okay. So these are the concepts we have in differential calculus. So integration, we have not touched the integration. So see some example problems in the textbook. And almost exercise problem, we have done all the problems. And here in this only one topic is there, find all the points of local maxima and local minima for the function f of x equals to x to the power of 4 minus x 8x square is there. Okay, only that problem is left for you. So for this example problem you have in your textbook. So with the help of that, solve that problem. Okay, so practice all these problems, whatever we have done for the 3 units. We have completed 3 units. Coordinate system is there, and next we have matrices is there, and third we have completed the differential calculus. Okay, so whatever the problems you are getting from this, so try to solve those problems perfectly and score good marks.
Excuse me, ma'am. Hello.
Yes. Yes,
Ma'am, in the matrices, ma'am, last class I have solved the problem. Adjoint of this, all the cofactors are 0. Okay. So adjoint is also 0, 0, 3 into 3 matrix, na?
Yes, null matrix. It is the 0 matrix. We have got that one.
Okay.
Okay.
So answer is also 0 matrix.
It is a 0 matrix. You can write, just you write it as a matrix. 3 by 3 is 0, 0, 0, solve.
Okay.
And a null matrix or 0 matrix.
Okay, ma'am.
If any other problem, get me same procedure you follow and you solve the problem.
Okay, okay. That inverse is not possible because it is it's 0 delta I,
So you, even first determinant also you got 0.
Okay.
Starting determinant A. You got some value?
Yes.
But whatever the determinant value is there, if you divide by 0 means all zeros only you will get no.
Okay.
So you will not get here A inverse value. Just whatever the values you are getting, that is a null matrix you have got. It's enough for.
Okay.
So,
thank you.
The asked only adjoint matrix only, I think so.
Okay. Adjoint only there.
Okay, adjoint he has asked.
Yes.
So, maximum and minimum concept is there. Only that problem is there. Almost we have completed the problems. So just slightly I will tell that problem. That is a local maximum and minimum is there. So one write the question from your textbook. Find all the points of local maxima and minima for the function f of x equals to x to the power of 4 minus 8x square is there. Local maxima and minima. Maxima and minima, okay?
Yes, sir.
So function is f of x equals to x to the power of 4 minus x square. So for this we have to find the differentiation. So if you want, you can write the step differentiate 1, you put 1 with respect to of x. Directly I am doing here. F dash of x equals, this is x to the power of 4. So x to the power of 4 differentiation is 4x3. What a coefficient is there here and 1 less, 4x cube. Minus here 8x square means 8 into 2 is 16x. Okay. So for finding local maximum and minimum, whatever f of x value, f dash of x value is there, no, that value you have to equate to 0 and you have to find the roots here. Okay. So that first we will do second order here. Second order means this is first order, no. For that if you do one more differentiation, it is second order. So this is 4 3s are 12 and 1 less, no, 3 minus 1 means 12x square minus 16. Okay. So this is second order. Now to find the roots, we will take, that is f dash x equals to 0. Okay. So that is f dash of x value, what f dash of x is equals to 4x cube minus 16x equals to 0. So here you can take 4x common. 4x common means x square minus here 4 equals to 0. Okay. So this is 4x equals to 0 and this is x square minus 4 is equals to 0. From this x value will get as one root as 0 and here it is in the form of x square minus 4 square. That is 4 means you can write it as x square minus 2 square equals to 0. It is in the form of a square minus b square. So a plus b into a minus b equals to 0. So you will get x plus 2 into x minus 2 is equals to 0. This one, okay. So if you take this as 0, you will get x value is one as minus 2, another one as 2. Okay. x plus 2 equals to 0 means x value is minus 2. X minus 2 equal to 0 means x value is 2. So we got root, that is x values are, therefore x we got one root as 2, another one is minus 2, another one is 2. Okay, we got x as 3 root values. That means when you substitute 0, minus 2, 2 in these equations, you will get the value as zeros. So that values are called as the root values or real values of the given function. Okay, so we got x equals to 0, minus 2, 2. So with the help of the second derivative test, first you substitute x value as 0. If you will get less than 0, then it will be local maximum. And if it is greater than 0 means you will get the local minimum. Okay. So here the root values are x is 0, minus 2 and 2. First you see f double dash of 0. F double dash of 0 means this is 0. Minus 16 means it is less than 0. Okay. Similarly, this is the negative value. F double dash of minus 2. F double dash of minus 2 means minus 2 whole square is 4. 12 was a 48. 48 minus 16 means 32. You will get it is greater than 0. Positive value you will get. And f double dash of 2 is also 32. You will get greater than 0. Okay. So at x equals to 2 and minus 2, the points are of local minimum. At x means these two you got greater than 0 and greater than 0. No. So these two are local minimum. And this is local maximum. So you see the sentences from the textbook. Okay. At x equals to 0, the point is local maxima. And whenever you will get greater than 0, here it is at satisfying the local minima conditions. Okay, like this you have to solve the problem. Whenever he is asking to find the local maxima and minima. Based on this, you have an example problem in your textbook. So with the help of that, you write the sentences is in between whatever it is there. Okay. So the local minimum points are 2, minus 2. Local maximum point is only 1, that is 0. Okay. Local maximum point is this, and we have further, it is at local maximum. And the points are, these two are minimum points, and the value is 32, we have positive. Okay. So like this, you have to solve the problems. So once if you have time, you see even the integral calculus also somewhat you may understand, you can solve the problems. Okay, students. Completed a problem?
Yes, ma'am.
Okay.
Okay, any theory part is there is from the textbook you see. Okay, so try to solve all the example and exercise problems what I have told and write exam well and score good marks. Okay.
Ma'am,
Yes.
from block 1, how many marks we can expect in the end term examinations?
How many?
How many marks of questions from all the 5 units? Math only.
Only maths means starting section A to 5 marks questions you will get.
Okay.
And here also you will get 2 10 marks questions will be there. Section B.
Okay.
So 20 to 30 marks you will get from this one. Each that is starting first block is mathematics you have.
Yes.
So 5 marks questions you will get. First 2 questions will be, first and second question will be from mathematics, and those 2 are the 5 marks questions.
Okay.
And similarly, section B also, first 2 questions are from the mathematics only. Those are 10 marks questions.
Okay.
So 40 marks you will get. So if you are, whatever the topics I have told, at least you can score 20 to 30 marks. Why? Because from the matrices, 1 10 marks question you will get.
Okay.
5 marks questions you will get from the coordinate system and also matrices.
Okay.
So differential calculus also, any short answer or long answer they may ask. So it depends on the examiner who will give the question paper. Okay.
Okay.
So like the previous examination question papers, means how they are asking the questions, from which units they are taking, and by that you can understand how to solve the problems.
Yes, ma'am.
Okay.
Okay.
Okay.